Hi there. So today we're going to solve this problem called product of array except self, which means that if we have given an array, for example 1, 2, 3, 4, we have to give the product of all numbers except the number at the current index. Alright. If we take the first example, at the 0th place where there is 1 in the given array, we are multiplying every other element 2 into 3 into 4 and assigning it to the 0th place. As the problem says, return an array answer such that answer I, the ith element of the resultant array, is equal to the product of all elements except the ith element of nums. Okay, right. So a naive approach that we can think of is that we traverse the array, and for each index we get the product of the left side of the array from that index and the right side of the array from that index, and then multiply them, and that would be the answer for that ith element. Now traversing the array once and then once for every index of the array, that means O of n square time complexity. Okay, can we come up with a better approach? Yes, we can. We are given that the prefix or suffix of nums is guaranteed to fit in a 32-bit integer range. So what we can do is we can get the prefix of an element and the suffix of an element and then multiply them in the answer array. How? Let's go through it. We'll take a vector and we name it res. Its size would be n, and initially all values will be 1. I haven't got n yet, so let's assign n to the size of the nums array. Okay, then we traverse the array from the start to get the prefix I plus plus, and our ith element of our resultant array would be multiplied by the current product. Current product is initially 1, and after we assign, then we have to multiply the current variable with the element of the array at I. Okay, this will give us all the this will give us the product of the prefix at I. Now we want the product of the suffix at I. How will we do that? We will traverse from the end greater than equal to 0, and I should go minus minus, everybody knows that, and then rest of I will be multiplied by curve again, and curve would be multiplied by the element at I, and then we will return the result array. We forgot to reset. Let's reset current to 1. Okay, let's check if this works. Okay, something's wrong. Redefinition of curve. Oh, we don't have to use int again. We can just reassign it instead of redefining it, and that is accepted for the basic test cases. Let's submit it, and it got submitted. So yeah, this is the solution, and the time complexity will be O of n. We traverse the array 2 times, once for prefix, once for suffix. And also note that when I solved this problem at first, I thought we could get the product of all the elements in the array, and then we can traverse the array and then divide it by each element and then get the answer. But that won't be a good approach because we might have zeros in the array and we don't know how many zeros we might have in the array. We might have 1 0, we might the whole array might be 0. And another drawback is that, as we can see, that our maximum element is 30 and our maximum length is 10 to the power 5. So if imagine if all the elements are 30, then we will have 30 to the power 10 to the power 5, which is I think it's even greater than the long unsigned long range. So that won't be a good approach. And since we are given that any prefix or suffix of ith element in nums is guaranteed to fit in 32-bit integer, then we will use that observation. Thank you.